Chapter 4, Lesson 2, Comparing and Ordering Rational Numbers. What's a rational number? Do you know? What do you think, Cadence? Okay. Okay. Rational. What did we work with yesterday? Okay. What else did we work with yesterday? Decimals. Okay. Today we're going to work with percents just a little bit. Rational numbers are any number that can be turned into a fraction. Any number that can be turned into a fraction. So that's what a rational number is. Some numbers cannot be turned into a fraction. Believe it or not, repeating decimals can be fractions, right? You made fractions into repeating decimals and vice versa. So rational numbers, anything that can be turned into a fraction. So these are considered rational numbers. 0.44, 0.1, 0.622. How would I change those to fractions? Tell me the first one. What am I going to do to change this to a fraction? What am I going to do? Cadence? Why 100? Okay, so 44 hundredths, right? If you read it, that's what you put underneath. Then you can reduce, right? You reduce probably by 4. Probably got 11 25ths if you reduced. Right? Okay. What about this little guy? Ryan? Mm-hmm. Yep, it's in the tens place. Reducible? No. What about this guy? Somebody you haven't heard from yet. What do you think? Kaylee, what do you think? Okay, it's in thousands. So we know what's going to go over the... Yep, 1,000. Is this reducible? What would you reduce by right away? Oh, mine's bad. Sorry. I was thinking about reducing. Ugh. What would I reduce that by right away? 2. Start small, remember? Okay, so that'd be 311 over 500. I'm kind of doubting that's reducible again. Because 3 and 11, I'm guessing that's all the farther it can go. Okay. Unless you found something different. I don't know. Any questions on how to do that again? We're good to go on that? Okay. All right, so the first thing we're going to talk about is we're going to talk about comparing decimals, figuring out which one's bigger and which one's smaller. Now, there's a lot of misconceptions about decimals. One misconception about decimals is, well, if it has more numbers behind the decimal, it's obviously the bigger decimal. Not true, right? We have to look at the numbers inside of that decimal to figure out which one's bigger. The other day, remember when I told you about our Jaybird Savings Bank interest? Remember I told you about that? And I said, okay, our interest is this, and my interest is this. And I asked, I think it was the other class, I asked them which one's bigger. And guess what half of them said? Why do you think they said that? Because it has more numbers. It does not matter how many numbers are behind that decimal to know which one's bigger. We have to look at the numbers inside of that decimal to figure out which one's bigger. But yes, you can add zeros. That's one way to do it. And that's what I did for them. I said, okay, now which one's bigger? Like, oh, 0.5. Okay. So yeah, add zeros if you need to add zeros. That's a good way. Another way to quick figure out if something's bigger or not. So I'm going to compare these two. This one and this one. Okay? And I know you can probably tell off the top of your head right now which one's bigger, but I'm just going to show you just a simple way to do it. Line them up, just like this. Put them on top of each other. And then start at this place value, because that's obviously the biggest place value. Are they the same? Are they the same? Are they the same? Oh, are they the same? Which one's bigger? So I know that one's the bigger number. Okay? That's just this really simple, easy way to do that. Okay? Even if I look at this one, a lot of people would say that this one's bigger off the top of their head. And are they right this time? Yeah, this time they're right. 3.74 and then 3.741. If I add a 0 here, like Merrick talked about, this one is still bigger. If I look, they're still the same. Okay? What about this one? Which one's bigger here? The second one? Because if I would add 2 zeros here, that makes this one bigger, correct? Okay, now what if I have something like this? I don't know. Which one's bigger here? 0.6, because I can add zeros behind that, right? And oh my gosh, this is 491, and that's 600. So think about it when you're doing decimals. Don't automatically assume that the more decimal spaces behind something, the bigger it is, because that's not true. Questions on that? All right. So now, we talked about decimals. Now we're going to talk about fractions a little bit again. So comparing fractions. One thing you need to make sure you have when you're comparing fractions is what? Common denominator. That's going to help you physically see what is bigger and what's smaller. Okay, remember what denominator is, that bottom number? What's the top number called? Numerator. Numerator and denominator. You know easy ways to remember those? Do you have easy ways? Some people forget. Yeah. Down, D down. And then sometimes numerator starts with N, and N means north and up. Numerator up. That's another way. Yep. So when you're comparing fractions, you first have to have the same denominators, and we're going to go through that again, how to find that, all right? And then what do you look at to figure out after that? What do you have to look at to figure out what's bigger or smaller? If you have the same denominator, what's the next thing you have to look at? That top number, right? That top number is going to tell you what's bigger and what's smaller. And a lot of times I like to think of pie. Okay, I like food, so I always think of pie. And I always think of like a chart. Okay, this one would have 4 pieces filled in out of 36. That's going to have 9 filled in out of the 36. Well, obviously, the 9 out of the 36 is going to be the biggest one. Okay? But be careful, because you're going to have negatives today. You might have negatives today. What if I throw that in? Now which one's bigger? Yeah, this one. This one's bigger now. Because when you have a negative fraction, that negative can go up to that top number. Okay? And then I would just look at that number. Okay, which one's bigger, -4 or -9? Well, -4. Okay, so be careful with those negatives too. Be careful with them. All right, let's talk about how to find common denominator again. What's a way you know how to find a common denominator? There's a few different ways, Zane. What's one way? Okay, so if I look at 5 and 6, I'm going to think, okay, what's a number that they both go into, Jacob? 30. And you know what's another way? Can I just multiply the bottom two, too? That's another easy, quick way to do it. So let's say I pick 30 and 30. Okay, if I change the bottom number, do I have to change the top number then? Yeah, I have to change that top number. Some people will go, oh, well, then it's this. Okay, if you change the bottom, you have to change the top. So how do I change that top number again? What do I have to do? What do I have to do here, Connor? Okay, so if I multiply them, I got 30. Okay. Okay, very good. So let's say, what did I multiply 6 by to get to 30? So what do I got to multiply 3 by? Yep. Okay. What did I multiply 5 by to get to 30? So what do I got to multiply 4 by? Okay. Don't forget that. Some people forget that. They aren't sure what to multiply that top number by. It's whatever you did this one to get to that one. Well, I multiply by 5, so I have to multiply that top one by 5. Okay. What about this one? What do you know about this one? What can I use for a common denominator here, Jacob? I can use 12. Can I use 24? Can I use 36? Sure. Sure I can. 12 is just my lowest common denominator. That's not a big deal. I can use any denominator I want that both those numbers can go into, but I think 12 is pretty good. If I'm going to use 12, can I keep this one? Yeah, it's already 12. So 4 times 3 gave me 12, so 3 times 3 is 9. What's the bigger one here? Okay, what if I go over here and I put negatives in here? What's the bigger one here then? 15 would be my biggest one. Okay. How are we doing so far? So far, so good? This isn't so bad, is it? Like, I feel like this is pretty easy. Yeah, I think so too. Good. Okay, what I want you to do on your papers, I want you to compare these. Do you remember these signs? We talked about these already, didn't we? Okay, so use those signs. Use those signs. Figure out, I should probably move this. Figure out and compare them for me, because this is going to be part of your homework today. You're going to have to use what we talked about, figure out common denominators, and compare them. You can write them on your paper. That's fine. Write them all out. That's great. You might want an example in your homework in your notebook anyway. All right. Which one's greater? First of all, what is used as a common denominator for this? Probably 24. That's my guess. So you multiply by 4 and 4. So what was bigger? What was bigger here? Your sign should have went this way? Okay, nice job. This one, I don't know which way you guys go, but I usually go down for some reason. This one, you probably use 36 as a common denominator? Maybe? So you multiply by 2, it still should have been like this. Okay. Oh, what do you use for common denominator here? 75. That's a tricky one. If you didn't know, what could you have done? Could you just multiply these two together? Okay, Zane, no calculator. No calculator. Put it away. You don't need it. You don't even need to bring it. Don't bring them. Don't even get them out. I don't know which one's bigger here. So 3 times 5, it would have been this way, right? That's a huge number. It's a huge number, right? And this one, you probably use 30. So it would have been this way. Are they all the same way? Yeah. Oh my gosh, I didn't try to screw you up very much, evidently. All right, very good. Any questions on this? Is it pretty... So I don't even know in your homework if you're going to have this big of denominators. I'm pretty sure it's going to be smaller ones. So, what? Yeah. Oops. All right. The next thing they're going to have you do is they're going to have you use a number line to compare. So you're going to have to make your own number line. They're going to give you 2, okay? And then they're going to have you make a number line, okay? So what I would do if I were you, first I would look at my numbers and I would say, what are these two numbers between? What whole numbers are these two between? 1 and 2? Negative 1 and 2, right? Negative 1 and 2. And if you look at the up there, negative 1 would be on this side and negative 2 would be on this side, right? And then what fraction do they have? 6. So then I would say, okay, this would be 1 and 1, 6. This would be 1 and 2, 6. 1 and 3, 6. 1 and 4, 6. 1 and 5. Oop, I can't get it. 5, 6, and they're all negative. And then plot your points. So, okay, 1, 6 is here. 1 and 5, 6 is here. Is that pretty easy? Fairly simple? Okay, just look at them, see what whole numbers are between, and look at what fractions you have. And if they aren't the same denominator, make them the same denominator so they're the same, and then make your number line. Questions on that? I don't even know how many questions are on that, so I'm guessing just like 1 or 2. Okay, so one of the last things I have to show you today is changing percents to decimals. You're going to want to know this and have this in your notebook, okay? Changing percents to decimals. You're going to use this today. Remember, these are all rational numbers, so we're talking about all rational. We talk about decimals, fractions. Now we're going to talk about percents because these are also rational, believe it or not. So percents to decimals. What you're going to do, you're going to move the decimal 2 places to the left. That's how you're going to change percents to decimals. Okay, so I have 45%. Where's my decimal in 45%? At the end, right here. Oh my gosh, if there's no decimal, it's always at the end. So, it's still a percent. I have to move this decimal 2 places to the left, to make it a decimal. Now, that is 0.45 in a decimal. If I have 23%, where's my decimal? At the end. Still a percent. I want to make it a decimal, though. When I move that decimal, it gets rid of this percent sign. That's my goal. I want to get rid of that percent sign. So I'm going to move it 2 places to the left. And 0.23 is my answer for that one. Now, if I look at this one, do I have a decimal already in that one? But do I still have a percent sign? So I still have to move that decimal to make it a true decimal. I want to get rid of that percent sign. And when I move that decimal, it gets rid of that percent sign. Goodbye. I'm going to move it 2 places. 0.345 is what it is in a decimal. Pretty simple. If you can remember that, you're going to be golden for today, because this is what some of your homework is going to have. Can I change the page, you guys? Okay, it's going to give you 3 or 4 different things, and they're going to want you to order them from least to greatest. Now, I want you to think about it. Can you put that in a decimal? Already in a decimal. Can you put this in a decimal? Can you put that in a decimal? Easiest way to do it, put them all in decimals, and then put them in order. Okay? What's this in a decimal? Yep, 0.23. That's already in decimal. Can you put that in a decimal? 0.25. You guys probably know that off the top of your head. And that one is 0.2. Okay, now I want to order these from least to greatest. So what's my smallest one up there? 0.2. If I put a 0 on there, right? That gives me 0.20. So when I order them from least to greatest, but I want to use the form they were originally in. Does that make sense to you? Don't put them in order with this. I want to know what they were originally in. So then what one's the smallest? Okay. And then what one? Yeah, so 23%, right? Because I'm going to put them in the order that they were in. And then 1/4. Okay. So we talked about all this stuff in the last 2 days. We talked about changing these to decimals. We talked about changing those to decimals. You can do it. Could you put all these in a fraction and order them? You could, but you know what? That would take a lot of work. Because you would have to have the same denominators, and it would just take a lot of work. Why don't you do, never mind. Do you want to do one for me to see if you can get it quick before you go? Okay, so let's do 0.31. Let's do 2/5. Let's do, I don't know, what else we got going on here? 45%. Put those in order from least to greatest for me. They might already be in order from least to greatest. I don't even know. Are they? Are they in order from least to greatest already? What? How does that happen? That never works out for me. Because I don't, what's this in a decimal? Oh my gosh. And this would be, seriously. It's on the board. Hold on.